We're Team Umbra, and this is our Hack Money 2020 submission. My co-conspirator is Matt Solomon, who built the front end and the JavaScript library. My name is Ben DiFrancesco, and I worked on the architecture and wrote the smart contracts. We built a protocol for privacy-preserving stealth payments on the Ethereum blockchain, inspired by this March 31st tweet from Vitalik Buterin. At a high level, Umbra enables transactions where the receiver's identity is known only to the sender and the receiver. So how does it work? Users publish an Umbra public key in an ENS text record. Payers generate a stealth address from a random number and the receiver's public key. Payers encrypt the random number with the receiver's public key and announce it in a smart contract that also holds their payment. Receivers can then scan announcements, find payments to stealth addresses they control, decrypt the random number, and use it to generate the address's private key. Receivers then withdraw tokens via gas station network, avoiding the need to fund stealth addresses with Ether. Gas can be paid for directly with tokens via Uniswap. I'll demo the front end for you now. I have two browsers open. On the right is the user who will receive the payment. On the left is the user who will send the payment. Before they can receive their first payment, our receiver has to configure Umbra. This is a one-time setup step. The receiving user owns umbrademo.eth. If the user didn't own an ENS name, they'd see instructions on how to register one. The user sets a password. This is used to encrypt the private key that is generated and store it locally. In the next step, the user is prompted to back up their encrypted key Finally, in the last step, the user signs a message with their new public-private key pair and publishes that message as an ENS text record. Payment senders will use this to derive their public key and generate new stealth addresses. So our receiver is all set up. Now let's hop over to the sender. The sender will navigate to the send section and then enter the receiver's ENS name. Umbra validates that the expected ENS record is present for the receiver. Behind the scenes, it generates a new stealth address using the receiver's public key and a randomly chosen number. Now our UI shows ETH and DAI, but since these are just simple transfers between normal Ethereum accounts, we can support any ERC20 token out of the box. I'm sending 12 DAI here. I approve the transaction in Portis, and that's it for the sender. It's that simple. Let's hop back to our receiver now. We're going to navigate to the withdrawal section and enter our password. Umbra will scan the blockchain for payment announcement events encrypted with our public key. When it does, it's going to find the DAI transfer that we just sent and give us the opportunity to withdraw it. Remember, the stealth address which received these funds currently holds no Ether. We can calculate the private key needed and using gas station network, withdraw the tokens to the address of our choice. It's important we choose one that is not tied to our identity. I've got one prepared here. With proper Uniswap integration in GSNv2, we can allow the user to pay for gas with tokens they've received and optionally swap to another token upon withdrawal. I confirm the transaction, and when I navigate to the extraction address in my wallet, I can see I've received the DAI withdrawal. That's been a quick demo of Umbra, privacy-preserving stealth payments on the Ethereum blockchain. Our immediate short-term plan is to finalize the MVP and get it to mainnet, then help other developers integrate and build with Umbra. Down the road, we'd like to explore other ways to make Umbra more useful and more efficient. If you'd like to try out Umbra, visit robson.umbra.cash and check out our GitHub for more information about the protocol. Thanks for a great Hack Money experience.